So thank you for joining the mock interview.
Yeah, my
Our
pleasure.
session today is going to be about 1 hour long. Okay. And
Okay.
then for the purpose of this mock, we won't do introductions. We'll just get right into it. All right. Let's just get into it. Save us time. We'll aim for 45 minutes of
Okay.
implementation. Okay, 45 minutes, and then 10-15 minutes at the end for feedback and questions. Okay.
Okay.
All right. What's your
Right.
preferred language?
My preferred language is Java.
Java. Okay. Let me switch that for you right here. Java. 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 Where is Java? Where's the search bar? Here it is. Boom. All right. Okay. Cool. All right. So for this problem, I'm gonna go ahead and just give you the problem description in a comment. All right, so we can
Okay.
just go ahead and just get rid of this. I'll put it over here. Okay, so I'm gonna give you this as the input. All right, please have a read. All right,
Okay.
please have a read of the problem and let me know if any questions.
So I'm given an array of meeting time intervals consisting of start and end times. Determine if a person could attend. Determine if a person could attend our meeting. Okay, got it. So everything is clear. So means that assume that S1 and S1 represent the start time and E1 represent the end time of the meeting, right? So
Correct.
we would have we I will type my comment here. We would have end meetings, and each meeting has its own start and end time, and determine if a person. So how do you define uh, whether a person is able to attend on the meeting? Is it necessary to join for the whole session or just enter the meeting
They had to attend for the whole session, the whole time.
the whole time?
Yeah,
So the person is considered to be attend the meeting. He has to be join all time, spend all time
correct.
on the meeting. Right. Okay, got it. Uh, so okay, so what is the input size of our the constraint? I mean the constraints of the input side.
That's a good question.
It's a
Let's say,
range
yeah, it's a good question. Let's say we have 1 million, up to 1 million meetings.
up to 1 million meeting, right? 1 million sitting and output. So from the description, I am assuming that our function looks like that we have the an array of meeting
Yeah,
and determine if a person could attend all the meetings. So we only have one parameter, right? Am I right?
yeah, just the one person with these meetings. Yeah,
More than one person would attend on the meeting. So our input, our parameter, there's only one parameter meetings, the meeting array starting the endpoint. So I think the solution for this problem is quite obvious that we want to, so instead of uh, we can restate the problem to find whether is there any two meetings overlapping with each other, right? It's more intuitive rather than so determining if a person could attend all meeting is equivalent to finding is there any two meetings, at least two meetings overlap with each other.
okay.
Okay, so is the meeting arrays already sorted or not?
Well, I want to ask you, what difference would it make if it was sorted or not?
The difference here is that assuming that my input is 1 3 and 2 5 correctly.
Hmm.
So I my naive my gut feeling is that I would if the input is already sorted, so that I just simply iterate through all the meeting from the start to the end, and you know after examining the first meeting, I know that this meeting ends at 3, right?
Hmm.
And that's 3. And then if I got to the next meeting, if the starting hours of the next meeting is less than 3, so I know that there's an overlap between the current meeting and the next meeting. I mean
Mm-hmm.
that I mean that if the if the start hour of next meeting is smaller than the end hour of the current meeting,
Mm-hmm.
so it implies that there's an overlap here. So that person cannot attend all the meetings. So we
Mm-hmm.
would return false. Otherwise, I keep repeating this process until I reach the end of the array. So that's the reason why I asked you whether the meeting array is already sorted or not.
Yep, that makes sense. So unfortunately, we cannot assume that it is sorted.
Okay, so if it's not already sorted, so the first thing I want to do is that I have to sort the array first, and then I would iterate the whole array from beginning to end to check overlapping. So because we have assuming that talking about the time complexity, we have n meeting, and the time complexity of sorting is O, big O of n log n. So my solution would have O n log n in time complexity. And talking about space complexity is the O1 because I don't introduce any auxiliary space here. So basically that is the my basically this is my final solution. But I'm thinking, is there any way to optimize it? Mm, is there any way to optimize this kind of thing? Do you want me to optimize this solution, or this
Nope, I think
solution
this is
is
fine to continue. No, I think this is good.
okay? So I would go with this solution, and can I start coding?
Yep, please go ahead.
Okay, so but just to clarify, that is my uh, does my solution align with your expectation?
Yeah, no, yeah, this is what I would expect.
Okay, so I could start coding. So my function would be static and the function would return boolean, and it can attend all the meeting array, and then that's it. Uh, what happened to the okay. One is that, so I would sort the meeting, and I would sort their array based on the starting time, right? So starting time is at index 0.
Mm-hmm.
It's just a syntax sugar for lambda function in Java.
Yep,
And
that's fine.
then I would handle the HK where the meeting length is 0. So there is no meetings. Oh, so is it the HK? So if there is no meeting, should I return false or true?
You should return true. You can
Okay,
attend no meetings, and that's valid.
okay. So I would return true for this AKH, and I would initialize a start pointer, a kind of pointer here. This is the end, the previous n hour. So initially, the previous n hours is equal to the first meeting n hour. And then I will iterate all through the array from the beginning to the end, starting from index 1. Mm, starting from index 1. And I would check whether the starting hours of the current meeting is smaller or smaller or is smaller than the previous n, I'm going to immediately return false. Otherwise, I would update the previous n to the current n. Where an hour, and then if everything goes well, eventually I would return true. Okay, so this is my
Cool.
implementation.
Okay, cool. Sounds good.
Okay,
Yeah,
do you
this
want
is
me to dry run? Do you want me to dry run throughout some example?
yeah for a real interview. The answer would be yes, but since it's a mock, I want to save us a bit of time, and I want to just move on from here. Is that okay with you?
Okay, it's totally okay
Okay.
with me.
Okay. So my first follow up for you for here, okay, is I'm gonna modify the problem a little bit now. Okay. So
Okay,
now you are also going to accept a second parameter k. All right.
okay.
Yes, and this k represents how many meetings you are allowed to miss. Okay.
How many meetings I am allowed to
That's
miss?
right.
Okay,
It's an integer. Okay. And so you
okay.
should return true if you can return. You should return true if you can attend all the meetings while missing at most k meetings.
Well, missing at mo k meeting.
Yeah,
Okay,
so
got
you
it.
can choose to miss. For example, in your case over here, if k equals 1, then you will return true because you can choose to miss one of them. Does that make sense?
Okay, that makes sense for me.
Okay, please modify your solution.
Okay, so mean that yeah, the problem is quite clear to me. So if I I am allowed to miss at mo k meetings, and well, this is the modification to the previous problem. Let me gather my thoughts a little bit. If I have k, I'm allowed to miss k. So okay, so I would keep my current implementation, but I would tweak it a little bit, meaning that you know, uh, during while iterating the meeting from the beginning to the end, if I encounter an overlap between two meetings, I would decrement the k by 1 unit, meaning that I miss the next meeting. No, I mean that I choose to miss the current meeting because the current meeting is overlapping with my previous meeting. And my objective here, my main objective here is to uh, join all the meeting as possible, right? So this is my objective. So the decision where, um, so the decision which meeting I choose to meet doesn't matter. I can, apply some greedy here, meaning
Mm-hmm.
that whenever whenever the current meeting uh, overlaps with the previous meeting, I always choose to miss the current meeting, to ignore the current meeting. I mean, so because uh, the order of uh, the order of ignored meeting or the combination of ignored meeting doesn't matter in this scenario because I want to join all of them, right?
Okay. Yeah.
So I just simply ignore the current one if the current one overlaps with the previous one. So it's in my intuition to solve that problem. So I think that there is no edge case here I have to deal with here. So does it make sense to you?
Yep. Please go ahead.
Okay, so I'm going to tweak a little bit. So I would introduce an additional parameter k. And if the current meeting overlaps with the previous one, and the k is still, and the k equal 0, meaning that I am not allowed to miss any meeting anymore. So I simply return false. Otherwise, if the current meeting is overlapping with the previous one, but currently the case is still larger than zero, so I'm going to decrement the k by 1 unit, and then I keep iterating this process until I reach I reach the final answer. Okay, so that's my implementation, and the time complexity for this task is still big O and log n because I
Okay,
have to sort
cool.
the array.
Yeah, for this problem, I would like to do a little dry run if you don't mind. So I'll provide an input for you. And you
Okay,
don't have to actually run the code. You can just walk it through. Okay, so this is your input.
okay,
And then let's say, I mean, let's just say for the sake of argument, k equals 1.
k equal
But,
1. Okay,
I mean, okay, yeah, please go ahead.
okay. So I have to walk through the sample, right?
Yeah, well, so first of all, what's the correct answer? True or false?
The right answer for this is the right answer for this is let me see. Okay, the right answer if 10 fonts should be some font.
Sure, sure, false. Why is that?
Should be font because the second meeting, two file overlaps with the first meeting. So I choose to ignore the second meeting. So
Okay,
the k is going to become 0,
okay.
and then uh oh no, there's if a flaw in my implementation because I can choose to ignore the first meeting.
Mm-hmm.
My implementation would return false, but the expected answer, the actual answer for this input is true because I can choose to ignore the first meeting and then join the second and the third meeting. And the second and the third meeting, they don't overlap with each other, right?
Mm-hmm. Yep.
They don't overlap with each other. So, okay, so there's a flaw in my implementation. So I'm trying to figure out how to solve it. Mm,
Mm-hmm.
so the decision of choosing the meeting to ignore is important, right? That
Yes.
decision matters. That decision matters. So the answer, so the problem would becomes which meeting should I skip? Okay, which meeting should I skip? So I'm going to let me see. Is there? Oh, got it. Maybe maybe I would think in another way, meaning that I can mm, okay, I can visualize it a little bit. Imagine that a timeline from I imagine I have a timeline, right? From one blah 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 to 100. So this is my timeline. So the first meeting lasts from unit 1 to uh, 100 unit, right? And the second meeting lasts from 2 to 5. And the second meeting lasts from 6 to 10.
Mm-hmm.
Okay. So looking at this graph, I see the first meeting overlaps with the second meeting, and the number the number of overlapping meeting is 2 for this and also 2 for this. So Let me think a bit. Let me think for a while. Okay, so we got it in. If we can eliminate this kind of guy, we can.
So let me quickly ask you about an implicit decision you made earlier, which is over here.
Yeah. Okay.
So what is this line doing? It is sorting array based on what?
Uh, that line sorts the array based on the starting time.
Okay, and why did you pick starting time?
The reason behind why I picked the starting time is that mm, I just want to make it order, so I can sort it based on oh because I want to simulate the behavior of joining the meeting throughout the timeline. So I have
Okay,
to sort the array from the beginning time to simulate. It's just a simulation, like joining the meeting and then exit the meeting and etc. So it's just for simulation.
okay, yeah. Um, the reason I asked you that is because the other decision you could have made implicitly was sorting by the end time.
It's sorting
Now,
by the end.
right now,
Okay.
now, what's the difference? Well, the difference is this, right? The start time of the meeting doesn't really tell us any information. The end of the meeting, I mean, obviously it has some information, but it's not the whole story, right? You have to consider the end time. The end time
Yeah.
matters because if a meeting ends a really late time, you
Yeah.
don't really want to attend that meeting if you can avoid it, right? Like for example, if a meeting ends at time 100,
Yeah.
and for some like if meeting ends at time 100, you want to pick this meeting last, right? Like for example, if this meeting ends at time 100 and it starts at time 1, then you almost certainly don't want to take it because it just takes so much time,
Correctly. So
right?
meaning that it's too lengthy. It's too lengthy,
Yeah, it's
right?
too lengthy. Now like that's different. For example, from a meeting like this, where it might not be like 100. It still ends at 100, right? But it might be like 60, right? This
Correct.
is different because yeah, it's still a long meeting, but you can see that we have a lot of meetings maybe over here in this area, right?
Yeah.
And then
Correct.
after this, then we can see, oh, okay, there is a meeting which goes to time 100, but now we can choose to take it if we want, right? The goal here is to understand that you have chosen to sort by the starting time, but you can also choose to sort by the ending time. So can you think about that and explore that idea a bit more?
Okay. So I would start thinking in a way that we sort the array of meeting based on the ending time. So if we do so, let's see, if we do so, the sorted array would become 2, 5, 6, 10, 1, 100, and 60, 15, right? Because if the ending time are equal, so we prioritize sort based on no if the meeting time if the ending time is equal, so we should prioritize the meeting with the higher start time because it has shorter duration, right? So we
Yes.
should prioritize 60 over 1. So
Yep.
if I do so, I would apply the same logic. But because I am sorting in in the end time, so I would store the previous end the previous end time and I would compare it with the current start time. So if they overlap, I would decrement the k by 1. Otherwise, I would keep the k and continue. For example, mm, if my I is 1. So I would examine this meeting with this meeting.
Mm-hmm.
But currently the previous end of the previous meeting is 5 and the current start time is 6. So there's no overlap here. So I just keep iterate and so far my k value is still 1.
Mm-hmm.
And then uh, the iterator is incremented by 1 and previous one now is 10. So 60 and 10, they are not overlapping. So the k is still 1. And then previous n equal 100. So 100 is overlapping. So they are equal. So we still keep the k equals to 1. So it passed the test case, right?
Mm-hmm.
So we have remaining 1. So what if this meeting becomes 101? So the arrays, the sorted array would look like this,
Mm-hmm.
right? Would
Yep.
look like this. And because at the or no, at the index 3, meaning this meeting, the 60th, the end time is within the start and end of the current meeting, so that I would decrement the k value to 0 and it's still valid. And in very um if you have 50 or any number smaller than 100 like 6, so my answer would become false, invalid, right? Because
Yep.
the 1 is in between 70 and 102.
Just to
So it's kind of,
clarify here, can you tell me when the previous n was updated to 100? Like you process these two,
yeah,
and then you're over here now, right? So you're in this case. Your previous is 10,
yeah,
and you're
correctly.
currently looking at this. Why is your previous n 100? Does it
No, I mean at index 3,
okay at
mean that
index three? You're
I'm over here. I am over here.
right, but if your index here, your previous n isn't it still 10?
It's no previous and it's still 10, 100. The previous and is the previous end hour of the previous meeting. I am in index 3, so the previous end is index 2,
Okay, so this
which
previous
is
n represents the meeting of the previous index, even if you don't take the meeting.
uh if I take the meeting. Yeah.
But in this case, you can't take 100, right?
Uh oh, correctly. This, oh my God. This case I cannot attend it. Okay, got it. Because 10 is between 1 and 100, so I would decrement at index 2, I would decrement k by 1 by 1. My fault. Mm,
Yeah.
yeah, so the previous end would be the end hour of valid meeting in the previous step. So it's still 10. It's still 10.
Yeah,
It's
it's
still
still
10.
10. And then when you're over
And
here, you can take 60, 101
yeah,
because
I
you know
can
overlap.
attend 101.
Yeah.
But in the next step, I cannot join
Yeah, and this one you
because
can't take. Yeah, that makes sense.
overlap.
Okay.
That- Okay. So er, okay. So but it counterintuitive because your hints that we should sort the array based on the ending hour, right?
Yeah.
But kind of counterintuitive to me because it's kind of greedy, you know. So I had to figure out why this algorithm works for all cases. So just okay, got you. So meaning that we are trying to Oh, we are trying to take the meeting that ends earliest, right?
Essentially, yeah.
Essentially. Oh, got it. So we would it's just agree here, just take the meeting. So there is a higher chance to complete the task. And yeah, okay, got it. So I see I got the idea. So can I go to code now or
Yep, go ahead.
okay. So I would tweak a little bit on this instead of sort on the start hour. We are going to sort based on the any hour and previous meeting. The first meeting is always valid, right? And again, if the meeting is k will simply return true, and if the meeting overlapping, we would no overlapping we would decrement k by one, but not updating the previous end because the current meeting is not valid, and else if the current meeting doesn't overlap with the previous meeting, we would update the previous end hour to the current meeting. So yeah, so my final implementation looks like that.
And just to be clear, for k equals 0, is it supposed to be like when k reaches 0, that means we can't skip anymore, or is it that we need to be -1? Can you just give me a bit of just double check the index there? Is that supposed to be 0?
Okay, k equals zero means that we have an overlap. We have an overlap and we cannot ignore it anymore.
Okay.
So but is overlap. So but my expression is for here to determine whether the current meeting is overlap. I can create the current meeting is overlap with the previous one if yeah if the current start time is less than the previous one. Yeah,
Okay.
correctly.
Sounds
Yeah,
good. Does the time or space complexity change?
the time and complexity doesn't change because we have to sort the array and we don't introduce any additional space here.
Okay. Taking some notes here on my side.
Okay,
Okay, so I want to change gears a little bit and now do a different problem, but with a similar input. Okay, so I'll
okay,
just type that down at the bottom here. Actually, I'll put it over here. Okay, so for
okay,
this problem, basically the same input. All right, so it looks like this. All right, and this time what we're going to be doing is I'll put the comment over here as well. Okay, it's a similar problem, except now instead of skipping meetings, these are now you have to figure out for all of these meeting times what is a maximum number of rooms you'll need.
what is the maximum number of rooms I need?
Yes, to be able to book
Oh,
all of these meetings.
so meaning that just to clarify, uh one room can only handle one meeting, right?
Correct.
Okay, so only one room can only handle one meeting. So so the timeline over here, the timeline at the beginning. Do you see what I am highlighting? I am
Uh,
highlighting.
Let me see. Yeah, I see you. Yeah, go ahead.
Yeah. Okay. So the timeline here makes me thought about overlapping, meaning that imagine that we have a timeline like this. So to answer the question, how many how many room uh at minimum how many room do we need? We simply count the maximum number of overlapping meeting, meaning that this meeting, the 2 5 meeting and the 100 meeting from 2 from timestamp 2 to timestamp 5, the overlapping is 2, right?
Mm-hmm.
Uh, 1 to 2, the number of overlapping is 1, and 2 to 5, number of overlapping meeting is 2, and after 5, the number of overlapping be, becomes 1 again. Am I correct? And then from
Yeah.
6 to 10, the number of overlapping increases to 2. And then from 10 to 16, the number of overlapping would becomes 1 again. And then from 60 to 100, it would becomes 2. Yeah. So among these observation, our final answer would be 2, because at maximum there are 2 meetings that are overlapping with each other.
Yep.
So instead of, so I can, rephrase the answer of finding the minimum of conference rooms required to finding the maximum overlapping, the maximum number of overlapping meetings. So I rephrase the problem to that question.
Yep.
So our goal would becomes finding the maximum number of overlapping meetings. So this is our objective. To do so, the idea that comes across my mind is we we sort timelines. So meaning that the idea I am thinking about is we combine, start time and end time into a single timeline, right? So,
Yep.
uh, meaning that instead of writing multiple lines for each meeting like that, when combining them into one timeline, it is going to become like this: two, 1 to 5, 6, 10, 16, 100, and 100, right? So I combine the start and end times to one timeline like this. I have to distinguish what does the number 1 mean. Is it the start or the end of the meeting, right? So it by iterating uh, this timeline from left to right, I can uh, keep track of the the number of overlap overlapping meeting, because for example, I am starting at the position 1, right? So far the number of meeting is 1, and then I got to the number 2, and I know that the number 2 is a starting hour. It's a starting hour. So there must be another meeting. Am I correct? There must be
Okay.
another meeting when I encounter the number 2, because I know that number 2 is starting hour. It's not the ending hour. So I when visit number 2, I would increase the number of ongoing. So the cow variable, the cow variable here represent the number of ongoing meetings, right? It represents the number of ongoing meetings. So at the of 2, we have 2 ongoing meetings. And then I encounter 5, right? and encounter file, and I know the file is the end hour. It's it's not necessary to know which meeting the file belongs to. I only care about this is the end of some meeting. Some meeting have to finish at the time at the at 5, right? Some meeting end at 5. So
Okay.
when encounter 5, some meeting have to end. So I would decrement the number of ongoing meetings by 1, which becomes 1 again. And then when
So I
visit,
have a question for you here. So how do you know that five ends a meeting instead of starting a new one?
oh, because I have an extra information attached to each timeline,
Okay.
to each time. So actually, I would have the ASIC here, the end here. I would maintain the extra information for
Okay.
each
Okay.
time.
Okay.
So
Gotcha.
that's the reason why I know files is whether the ending or the starting hour.
Okay.
And then I read 6, and I know that 6 is the end hour. So the count would become 0. And I know the idea, right? I keep repeating this process until the end of the timeline. And during traversing during iterating the timeline, I would keep track of the max value of count. So and after finishing iterating the whole timeline, I can finally return the correct answer. I can finally return the minimum number of conference rooms required to host all these meetings.
Yeah, that sounds good. For the
Okay,
sake of time, let's just see how much of it you can implement. You can go ahead and I mean we'll see everything in a couple minutes. I don't want this to drag on too long, but I do want to see some coding skill here. So let's just go directly to that.
okay. I'm going to start coding that. So equal distance and return oh, a minimum rooms would return n. So I would have the int array here. I have the timelines and then the size. So we have n meeting, right? So the timeline is double. The length of the timeline is double. And then for for meeting in meeting, I would so I would have the cursor here, timeline index would add the starting time to m. Oh no, it would be the, so it would be the starting time, and I want the number 1 means starting time. Oh no, the number 0 is starting time. Like that. And the timelines of index. So I would append the ending time. So the number 1 here indicates the ending time, right?
Yep.
Okay. So I then, after appending the starting time and the ending time to the timeline, I'm going to sort the timeline and what my lambda, my comparator would looks like. I would prioritize the starting time first, right? So if starting time of no no if uh, a let me see. Okay, if the time of A equals to the time of B, not equal, I simply return A minus B, meaning that I prioritize a smaller time. And if they are equal, I would prioritize the uh, the adding time first, right? I would prioritize the adding time first because I have to finish before starting the new before starting counting the new meeting. So it must be reversed because the ending time have as the weight of one. So I have to reverse this expression.
Yep.
One. Okay. There's some syntax error here. Why? Okay. And then for in y equals 0, I less than 2 times n, I minus minus, and I would keep track of the answer. Answer is currently 0, and my now indicating the ongoing. So if timeline I, if it's either starting meaning 0, I would increment the count and update the answer to count. Otherwise, I would decrement the count and my final answer would be answer, the value of the answer. Okay, so this is my implementation, mean that 0 means start time, and I mean that uh, if times are equal, prioritize starting start time, no, prioritize end time
Yep.
before start time. Yeah, start means 0 and means 1, so that is the reason why I reversed the expression.
Yep. That makes sense.
Okay,
Just to wrap this up, time and space.
yeah.
What are your thoughts on the time and space for this?
Uh, what's on the time and space for this is O n log n because let me elaborate it.
No, you don't
It
need to
takes
elaborate. I'm just checking your answer. In login is after
yeah,
time or space.
and the space is O n because we have the additional timeline here.
Okay.
The timeline right here, so it must be O 2 times n, which is approximately O n.
Okay. Do you think that is optimal?
Uh, is this optimal? I think that about the time complexity is
Hmm.
a optimal, but
Okay.
by I can further optimize the space by how about reduce the meeting input? How about reduce the meeting input at the? Is it possible? No, I think it's currently I think it's not possible to reduce the meeting array. So, my temporary answer is that I cannot
Okay.
optimize the space further.
Okay. That's good. That's correct. All right. So I'm gonna wrap this up.
Yep.
Go to the feedback.
Okay, I'm ready.
All right. So I mean, before I go to the feedback, I usually ask, how do you feel about how you did today?
Yeah, I'm feel a little bit good,
That's
confident,
good.
but
Okay.
I'm a little bit depressed because I cannot solve the second the second problems. It kind of simple, but I cannot figure it out because I'm think that I thought too fast. I'm so hurried
Yeah.
to jump in the second problem. So
Yeah.
I was too confident about my implementation in the second problem. So that is the reason why I cannot finish it because I got
Okay.
no scared.
Okay. But how about the first problem? How do you feel about your handling the first problem?
Uh, Yeah, the first problem is quite obvious, so I have nothing to do to talk about that.
Okay. So it sounds like your first problem you thought were pretty good, and then the follow up for this first problem needed a bit of help, and then the second problem, or I guess if you count the third problem, I guess it depends on how you count it. That one you kind of rushed through at the end, but I think you actually did pretty well, all things considered. You know, it was a tight time, right?
Yeah,
Um,
it's yeah, correctly.
yeah. So I mean, overall, I think performance here was actually quite strong. Okay, I think there was a couple of things here that I saw that were really good, and we'll talk about that. And there were a couple of weaknesses too, right? And we'll talk about that. I think there's a
Okay.
really good, strong thing I want to just kind of highlight at the start, which is whenever you were thinking about a problem or whenever you were thinking about continuing on to the next step, you're always checking in with the interviewer about how they felt about a certain solution or how they felt about a problem or how they felt about your approach. That's very good, right?
Yeah.
So one thing you're gonna have to do is, depending on the interviewer, first of all, you should always start with this, right? But when you, depending on the interviewer, some of them are going to be very receptive, then they'll be giving you feedback along the way. Some of them won't be doing that, right? But even for the interviewers who will not be giving you any feedback along the way for you to bounce ideas off of, it's still not a bad thing to ask them at the start just to get a read on them, right? You know, just to see, okay, is this guy going to help me? Is this guy not going to help me, etc. So that was a
Yeah.
good strategy. The second piece I want to
Okay.
kind of highlight that was good was you were good at talking while implementing. So that's a weakness I see a lot, but it seemed like you got that part down pretty good. So whatever you're working on for that, make sure you keep that up. That's very good, right?
Yeah.
And
Okay.
then just to go into a couple of things I thought, just to wrap up the other things, the time complexity very fast, space complexity very fast. I think you're very confident in that. So I think you've done some good studying there, right? Now, I mean, obviously, this is a really simple problem for time and space complexity, but either way, I think the confidence there I think that shows through. That's really good. Now, one quick note about the space complexity for the first problem. I probably should ask you to not delete your old code, but you previously said the old space complexity was 01, but that's actually incorrect because
Okay.
when you sort in Java, that uses when you sort primitives in Java, it takes a login space because quicksort takes login, and you need to be careful about that, right? So when you sort primitives in Java, that is login space because it uses quicksort, and when you sort
Oh,
objects in Java, it's linear space because it's using temp sort.
oh, really? Yeah. Thank you for that. I didn't know that before.
Yeah, so you want to just check up on that. I think that kind of mistake the interviewer will understand. So it's not like it's still wrong, but it's not like horrendously wrong. It's just regularly wrong. It's not too bad.
Yeah.
Um, okay, cool. So now I'm going to a couple parts which I think can be probably improved. The first thing is, and this is the main thing I guess for this what I see in this mock is we were talking about the first follow up, and we were talking about how we can sort the array. So
Yeah.
first of all, it's very normal for a student to not be able to get that question by themselves. Okay, so don't feel too bad about that. Now,
Okay.
specifically, this class of problem is known as the activity selection problem. So in the notes I'll send you afterwards, I'll link the Wikipedia page for this algorithm, and you can go study it yourself. It is basically it is basically just theory and your intuition about how to make greedy algorithms work. And so I think the main lesson for you here is to understand there is a difference based on how you be greedy. Like there is a difference for these kind of problems if you're greedy based on the start time, the end time, depending on like other parameters, like different question, it might be greedy on the cost, greedy on the time, greedy on the location. It's like so there's different there's a lot of different attributes that you can use in your quote unquote greedy algorithm. And that
Oh,
for at your level now, that choosing what attribute to use is the demonstration of skill, right?
yeah.
So that's going to be a big part there. Now, that being said, there's actually many ways to solve the follow up. So later on, you can go search at Wikipedia. You can search at the Leetcode problems. Like these are all based on Leetcode problems. Okay, so you can go. You can see
Okay.
other people's solutions, see what kind of other approaches there are. For the second problem I gave you, there are basically there's four approaches that I would say a
Really?
good student should be able to. Yeah, correct. There are four optimal approaches. The first is min heap. The second is what is known as a sweeping algorithm. That sweeping line algorithm is not really used very much, but it's good to know that it exists. The third is two pointers. So you have a pointer for the start times and a pointer for the end times. And then the
Yep.
last one is one you did, which is greedy.
Great.
So these kind of problems, what I'm getting at, it's not saying that I know all four. What I'm getting at is these kind of problems, there are four separate patterns that can be applied. And it would really
Okay.
help you to know that there are other approaches. Why is that important? That's important for a couple reasons. First of all, if you get stuck on one, you can switch gears. Second reason, when you do time and space analysis, you can be much more confident in whether or not your approach is correct. For example, if this problem came up and you knew that, for example, right, and this problem came up and you knew that min heap was an optimal approach, then you would know for sure that n log n is optimal, right? And then O in space is also optimal, right? But the
Right.
reason I ask you that, the reason at the end I ask you if you're confident that's optimal is to check how many connections you've made between these greedy category problems and other category problems. Because one thing you might encounter if you as you practice Leetcode or these algorithm problems is that greedy problems oftentimes there's a lot of different approaches that are also applicable to the problem. So when you study these problems, don't just study one approach. See if you can do more forms of connections. And when you get a critical mass of a bunch of different connections, then that starts unlocking the ability to solve much more difficult problems. So I
Okay.
think you're on the
Got
right track. I think you've done some really good prep so far. And I don't think it would be too much effort for you to start being able to hit those hards. Because I think today you had some pretty strong performance in the mediums.
Okay. So another question is that am I rambling a lot of, or just totally fine?
I think the amount you talked today was pretty okay, pretty good. I think the
Yeah,
only
but
comment I would say about you quote unquote rambling is I think when I wasn't talking, you were talking a good amount. And then when I was talking, you gotta make sure that you internalize whatever I said. So that's
yeah.
the only thing I'll say. But the rambling part is fine. I don't think, especially if the interviewer is not talking at the same time, I think we did is fine.
Okay, got it. But how about my explanation skill? Is is it hard to you to follow my explanation, or is it easy to you to follow my, follow my workflow?
So that I would say there's two things there. The first thing is that um, that's not. So first thing I'll answer the question directly. I can follow it very easily. The issue with that is that I can follow everyone very easily because I understand every problem. So what
Oh,
what
okay.
what you really need to do for that is you need to go do a mock interview with another student and then ask them if they understand. If you ask me, obviously I understand everything. Like I made this problem, okay? So what you need to
Yeah.
do is ask someone else. Now, what I will say is that for real interviews, most interviewers know their problem quite well. And
Yeah.
so any risk you have there is with things that are outside of the problem. So for example, if you're concerned about whether the interviewer knows about your pointers, I'm sure they know. Okay? What they might not know are things like, for example, what are you like? What is the goal of you conveying this? Are you telling me this because you want me to approve it? Are you telling me this because you don't really know what you're doing? You just want to write it out? Are you telling me this because you're trying to buy time to think of something better? Right? That meta level discussion, that's something you got to be thinking about, and that's what interviewers will be looking for. Right? This is also why earlier I cut you off with your explanation. I cut you off with your analysis because I don't care. Right? We want to move on, right? For a real
Yeah.
interview, they won't cut you out. They won't do that to you, right? But
Yeah.
for mock, I will because I don't care about being polite. So you need to make sure that whenever you do whatever talking you do, right? It's not just about is the words correct, right? The words correct is level one. Level two is should you be talking right now? That's level two, right? So think
Okay.
about that whenever you're doing the practice, whenever you're doing other mocks, right? It's not just about talking. It's not about knowing what the next step is. But yes, I
Okay.
understood you fine.
Okay, those are really helpful for me, and it's a really great experience for me to join in the mock interview like that, because yes, because I have someone to give advice and feedback on my performance. But yeah, anyway, I think that time's up. Exactly, right? So again, I'm really be grateful and thankful for your time, because I do it for I can join your
Yep.
session for almost for free, right?
I mean, I hope it is free. I hope you didn't pay anyone because I don't charge. So, um,
Yeah.
but anyways, thank you for your time. I'll take care.
Okay, but take care. Thank you.